Hi everybody, welcome back. Today we're going to look at transitioning from lines into space in sort of a more traditional way of writing things to more of a vector representation. So to start, we want to look at our good old-fashioned y equals mx plus b sort of equation. We want to remember what various pieces here mean. So 2/3, one of the key parts of our equation, is of course the m value, the slope, and the -4. Here. The -4 is of course our b value, which represents our y-intercept. So what those allowed us to do previously was of course graph. The y-intercept is the point on the y-axis where the line passes through. The slope tells us how to get to another point given the fact that we have one to start. So from this point, we go up 2 spots, we rise 2, we run 3 to get to that spot. And of course, that gives us a definition of how our line is going to look. Now, if we think about this, kind of move into as we move towards the vectors idea, what the 2/3 has done for us is it establishes our direction. So the 0, -4 is a point. So to start, the -4 is the y-intercept, but more specifically, or say less specifically, it's just a point that happens to be on our line. It happens to be an easy point to find, but that's really all it is just a point. 2/3, 2/3, tells us how to, or which direction to go to find another exact point. Certainly, again, there's an infinite number of points along this line, but if we want one more that's nice and easy to recognize and to find, oh, there it is, by going at this angle of 2/3, if you will, by this direction of 2/3. As I continue in that 2/3 direction, oh, here's another point on my line, and so on. So essentially what we need to draw a line or to establish what a line looks like is a single point, kind of a focal point, and then some sort of direction. Of course, if you sort of think about if we just had the point, then our line might look sort of anything like any of these. And of course, if I only had a direction, then my line could be anything like this. By having the 2 values, I know exactly where the line is and what direction it faces. So what we'll have when we go into vector notation, of course, is the same idea. In this case, based on the 2/3 being our slope, the direction that we're actually traveling, if we think about it in terms of vectors, it is obviously the same, but it ends up being what we have been referring to in vectors as 3, 2, because we think of it, we always write it in terms of the x value first. So we're going across 3 and up 2 to get that. So if we look at this in terms of writing it as a vector, and this is just the purple is just the format of how a vector equation looks. We establish our vector x, y exactly as we always have. The vector 3, 2 is a vector. The vector x, y in this case represents some vector. We have a point, 0, -4. Okay, so right away when you look at this vector equation, the first thing you'll notice, or the first thing that sort of jumps out at you, is probably the fact that I've got a vector notation here for something that I'm calling a point. Now, without getting into it too deeply, basically the idea is that if I have some random point on the line that we're dealing with, so let's take this point right here, and we'll call it the point xy. When we start dealing, and sort of what we're looking at here is now, we're looking at a way to establish vector notation for lines, because of course when we get into 3 dimensions, things like slope and y-intercepts and so on, well, not y-intercepts, but things like slope to establish direction isn't going to be enough. So we're sort of making the transition from what we've seen before to vector notation so that we can then continue to use vector notation later on. So the basic idea here is that if I'm trying to establish the location of a point, it's essentially I'm looking for the distance and the direction of that point from the origin. So essentially there can be a vector here. If I have a end on my vector, I do, it's too small to see. So we can draw a vector to any point on our line. To find that value then, what we'll end up with is a combination of the vector that leads us to this point and some multiple of the direction vector, the blue vector actually that I just deleted, I didn't mean to delete it, that's going to take us along that line. Okay, so really what we're doing here is we're establishing a way to find a point on a line, eventually in 3 space, but for now in 2 space, when I can't deal with slope in a traditional sense. To do that, we need to have a location for a point, which can be established by drawing a vector from our origin to that point, and then a way to sort of have a, because this is a random point and I don't really know where it is, I need to have a fixed location, the point 0, -4 in this case, whatever the point is that we know is already on our line, and then information about the direction to travel in order to find the point that I want. Okay, so for our purposes, we can think of this as this is the equation. XY now is the location of a specific value that we're trying to find. It's giving us a point, or really again a vector to a point, a vector to a starting point, plus the direction to travel, and the t being just kind of the t being a scalar value means it's some multiple of this that will establish how far I have to go to find my x. So I know the direction is this direction, but do I have to go twice as far as that, 3 times as far as that, negative twice as far as that, or what, to find this px value, this pxy that I'm looking for? It depends on what the actual value I want is. Okay, so again, what we need to take away from it is that there is a point established, again, a vector to the point really, and then a direction value established by, that'll be that'll have a scalar multiple to determine how long up and down the line I have to go. So that's vector equation. We do have a couple of other forms of equation that we'll see, but really they're variations of the existing vector equation. And so if we look at this one, and this is actually work that we've done, we just didn't talk about it in terms of lines. We've determined before that our x value, when we have some sort of vector addition, is always established by the x values of the 2 vectors that we started with. In this case, essentially, this x value will be the 0 from here times, I guess, the 1 up front, because I have a vector directing exactly to that point, plus the x value here, which is whatever t is, times the value, the x value of the direction vector. The y value, of course, same thing, is the -4 here. It doesn't have a multiple, it's multiplied by 1, plus 2 of the t's, whatever the t value is that helps establish how far along my direction vector I'm going to go. And then the last one here, symmetric equations, I guess, is basically taking our parametric equations and solving for t. So again, just sort of knowing that t is a constant value, it's something that we'll likely want to be able to find, or in some cases it's a value that, because it's consistent throughout the various parts of the equation, can help us kind of set up, in this case, symmetric equations, so that we know that, so we know how x values and y values relate, and of course later on how the z values relate as well. So simply taking the parametric equations here, isolating t is the same as x over 3, t is also the same as y plus 4 over 2, and again later on it'll be the same as some expression in terms of z, so that we can line them up and then we can work with those if we have the information. So if I have an x value, I can find the y value exactly as I did before, even without having to worry about what the value of t happened to be. And I just have a little note here that I had used in the past, maybe of interest or of necessary to see. Just in some of the work, you will probably see the words starting from the standard form of an equation, or rewrite in standard form of an equation, or something along those lines. And standard form just means x's followed by y's followed by the numbers. I know I've had a number of questions this year where the answers in the book were written this way, and I was encouraging you to write as y equals mx plus b. Of course, you should be able to very quickly rearrange one to see if it lines up with the other. If I see that I have the book says 2x plus 6y plus 3 equals this, and I have some combinations of y's with 2's and 6's and 3's, rearranging them will allow me to see whether my answer is exactly the same. Okay, so basically, again, we're just kind of, for today, changing from this form to this form, a point, but again, really a vector to the point, a direction vector to explain where we're going as far as what direction we're going from our point, and that allows us to find any values, any x, y points on the actual equation.